All right, folks, it looks like you have mastered the basics and you are now ready for what we're calling next level strats with exponents. First thing we're going to start with is what I call the power play. So this is when you have two exponents, and it looks a little weird. You have an exponent here, do you see that little 3? And then there's a 2 on the outside. And so what you want to do is just really understand what that means. So if I have x to the third to the second power, what does that mean? Well, hopefully you guess that what that means is that the x to the third is going to happen twice. Stick with me through this. Okay, so what that means is x to the third goes 2 times. So x to the third times x to the third. So if we are just going with the whole basic rule of just x to the third means x times x times x, and then the second x to the third just means x times x times x, I know that I'll have a total of 6 x's. What I'm going to ask you to do a lot today is sort of look for a pattern. Look for patterns here. Okay, so let's get on to that next slide, which I'm going to have to drag from down here. Here it is. All right, I want you to look at this pattern here. What seems to be happening? So in the very first one, I have 5 to the second, which means x to the 5th times x to the 5th. I should say x to the 5th to the second, which means x to the 5th times x to the 5th. That's going to give me x to the 10th. 5 x's and 5 x's will give me 10 x's. X to the 7th to the second means x to the 7th times x to the 7th. 7x is here, 7x is here, which will give me 14. In the same vein, x to the 4th to the 3rd will give me x to the 4th times x to the 4th times x to the 4th, which if I add 4 plus 4 plus 4, I'll end up with 12 x's. So what I want you to focus on right now is I want you to focus on this part. What's the pattern? What's happening here? And I want you to take a guess at what x to the 3rd to the 6th is. Okay, so if I were still looking to multiply that out, I would have to write x to the 3rd 6 times. Okay, promise not to take all day. 1, 2, 3, 4, 5. I need one more right on her tummy. X to the 3rd. Now, if I were again just in the expansion area where I wasn't really as comfortable with what this means, I could then go ahead and write out 3x's, 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 3, and then count all of it up. But hopefully at this point you can put that together and know 3 plus 3 plus 3 plus 3 plus 3 plus 3 is going to give me 18. So x to the 3rd to the 6th power is 18. All right, let's continue. What do you do if you have coefficients? Okay, so what am I talking about coefficients? I'm talking about the 3 in the front here. So now it's x to the 3rd to the, 3 times x to the 5th to the 3rd. Boy, I'm having a hard time talking here. So what that's telling me is it's 3x to the 5th, 3 times. 1, 2, 3. Where is that 3 coming from? Right here. That exponent is saying, hey, do this whole thing right here 3 times. 1, 2, 3. How do you do it? Multiply the coefficients and then just count how many x's in all. Hopefully, when you did that, you got 3 times 3 times 3. Well, it's 3 times 3 is 9. 9 times 3 is 27. And 5x's plus 5x's plus 5x's is 15x's. Now, if you're saying to yourself, I'm not sure I can go from here to here, no problem. Absolutely write it out. You'll hear me say that a bunch of times. When in doubt, write it out. So just expand it. You do not have to memorize a single rule here. All you have to do is understand how to expand, which again keys back to the whole multiplication game. So do not hesitate to just expand it out the way I did and then come up with 27x to the 5th. All right, let's continue on. I'm going to ask you to try this one. I don't know where all those little flip charts are going off into nowhere land. Try this one on your own. All right, so hopefully you took negative 4 x to the 4th and you wrote it 3 times. Negative 4 x to the 4th, negative 4 x to the 4th. You then did 4 times 4, or negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. I always say collect all of your coefficients first, then worry about collecting all your bases with exponents. Okay, so variables come second. X to the fourth, that means 4x is here. 4x is here, and 4x is here. Let's see, 4 plus 4 is 8. 8 plus 4 is 12. So I know that I end up with, I've changed colors, but that's okay, x to the 12th. So just to reiterate one more time, if you're a little bit confused about what just happened, 4 times 4 times 4, 64. X to the fourth times x to the fourth times x to the fourth, x to the 12th. Okay, you ready for this to get a little more challenging? Here we go. We're going to go on to division. So how does division work differently? Well, it's hard to see on my horses over there, so I'm just going to write this out off to the side so you can see this. We're doing x to the 5th divided by x to the 3rd. Okay, so we all know that the fraction bar means division, so you can write it in a different way. I'm going to write it as a fraction. X to the 5th, you all know, is x times x times x times x, 5 x's. X to the 3rd, 3 x's. So when we multiply, all you need to do is find ones and cross them out, meaning find things that when you divide, you'll get 1. So x over x would give me 1. That's gone. X divided by x there will give me 1. That's gone. X divided by x there will give me 1. That's gone, which will leave me with 2 x's and gives me an answer of x squared. Hopefully at this point you're sort of noticing a pattern. All right, I'm just going to write this back out over here. Gives you x to the 2nd power. And don't lose your mind trying to tell me the pattern right now, but just be looking for these patterns over and over and over. Okay, let's continue. You come up here. Okay, so I'm going to ask you to expand this out, reduce, and tell me what you think it gives. All right, so x to the 7th. Ooh, be good if I wrote with a pen. X times x times x times x times x. 1, 2, 3, 4, 5, 6, 7. So you're going to find why we sort of want to look for patterns here so that we don't have to write them out. Because if it was like x to the 17th, this would take me a long time. Looking for ones. I'm looking for things that reduce to give me 1. Those guys would cross out. These guys would cross out. What am I left with? X to the 1, 2, 3, 4, 5. And again, look for patterns. I want you to focus on some numbers here. Hopefully it'll make some sense to you. But if you are not there yet and you just want to write it out, keep writing it out. You'll get the same answer either way. Okay, you go away. And let's bring this guy back up. Okay, so hopefully at this point you're thinking, oh, geez, what do I do if I have coefficients? Meaning, I don't just have x's, I also have numbers. I'm going to encourage you to always think of your coefficients as separate from your variables. Okay, so go ahead and write this out, reduce it, and tell me what you think you get. All right, when I write this out, I get 12 x to the 8th. I'm going to write all 8 x's out. You do not need to do it, especially if you are to the point where you kind of see that pattern. 1, 2, 3, 4, 5, 6, 7, 8. On the bottom, I have 4 and then 5 x's. Those are my little multiplication symbols. And now I'm just going to look for ones. These guys will cross out. These ones will cross out. Those will cross out. Those will cross out. Oh, I'm still crossing. Boom. Done with all of those. I'm now going to match up coefficient to coefficient. And I'm not going to do any trick here. I'm just going to reduce. So 12 divided by 4 will give me 3. Don't write with a highlighter. And then how many x's are left over here? 3. So x to the 3rd. Again, look for patterns. Notice what these numbers give. The quicker you find those patterns, the easier this will be for you. All right, now it's time for you to choose the level that's right for you. You go away, you get big. So pick your pal. Which one's right for you? So obviously Big Daddy Joe's the hardest. Baby Boy Brian is probably the most basic. go ahead and write it out. Yes, I've gone to the point of getting way expanded ones, but I think you can handle it. All right, folks, so I'm just going to show you how to do one of them, probably the most complicated one, just so you have some experience in seeing how it's done. I'm going to write a little small so that I can fit all this on the screen. Let's get started. So you're going to see a lot going on here with this very complicated problem. You have ones where you're using an exponent, okay? So these are both what we call powering or exponents. And then down below, I have one that's just multiplying. So really you're doing multiplying, exponents, and then once we get that reduced, you'll also be dividing. So you're doing everything in one. It's a whole big chop suey event, which is fantastic. So on the top row, I'm gonna do 3x to the 5th 3 times. In this round, I'm gonna write it all out. You totally don't have to. If you are already to the point where you can take all the shortcuts, you feel free to do that. But just to help out my friends who are still sort of developing an understanding of this, I'm going to write it out. So what did I just write out? This part here. Okay, I'm going to take the next chunk, and I'm going to do it in a different color just so you can sort of follow along. The next part is 2x to the 2nd 2 times. So I'm going to write that twice. And then the bottom row, I'm just going to multiply right away. So I'm going to match up coefficient to coefficient, 3 times 2, and get 6. I'm going to match up variable to variable, x to the 4th times x to the 6th. That'll give me 10 x's, which is x to the 10th. All right, so now I'm going to multiply everything across the top, and then I'll be able to reduce. Once again, coefficient to coefficient. I'm going to keep trying to match up to make my life easier. So I'm going to multiply 3 times 3 times 3 times 2 times 2. So 3 times 3 is 9, times 3 is 27. 27 times 2 is 54. 54 times 2 is 108. So I end up with 108 x to the, I'm going to basically count up all my x's here. So I'm going to match up all the same variables, x to the 5th, and x to the 5th, and x to the 5th, and x to the 2nd, and x to the 2nd. So this is 5x's plus 5x's plus 5x's, which is 15x's. And then there's 4 more x's. So I end up with 19 x's here. So 108 times x to the 19th divided by, and I'm just going to bring down 6x to the 10th. Okay, I can now go ahead and reduce my fraction. I can also cross out. Now, I could write all 19 x's out and all 10 x's out and then look for ways to cross out. But you know that all 10 x's on the bottom are going to cross out, leaving only 9 x's on the top. So again, I've said this before and I'm going to keep saying it over and over. Variables to variables, coefficients to coefficients. So we end up with x to the 9th because there are 19 x's. If I wrote out 19 x's and 10 x's, I'd end up crossing off 10 x's. And then 108 divided by 6, does it go in evenly? I think it does. 6 goes into 10 one time with 4 left over. And so 6 goes into 48 8 times. 6 times 8 is 48, which gives us this beautiful answer of 18x to the 9th. Awesome. Last question that I have for all of you is, how much do you love exponents? What questions do you still have?